Now yesterday, the first report about what it's doing closest to the Sun came out. These are instruments that are capable of looking very close to the Sun, and it was realized that in fact, the object is brightening. It becomes very bright right now as it comes close to the Sun, and it's turning blue. And the color blue is very surprising because if there is any dust shed off a natural nucleus of a comet, the dust would make it red. And usually, the surface of the object is at least an order of magnitude cooler than the surface of the Sun. But what the new data indicates is that the object is bluer than the Sun. How is that possible? This morning, we have a report that the object got much brighter than expected, and moreover, the color of the object is blue, bluer than the Sun. And that's very surprising, because usually when there is dust around an object, it should make it red. I should also say that the news yesterday was that this object came closest to the Sun, and it received a huge amount of heat from the Sun. And the latest report indicates that it became extremely bright, much more than expected for familiar comets. I-Atlas has stopped moving, or so it seemed. To the astronomers watching, the stillness was inexplicable. An object that had blazed its way through the void, leaving a trail of light as it approached the Sun, now appeared frozen against the starfield. All motion gone, the initial shock rippled through observatories like an electric pulse. How could something so visibly alive in motion suddenly stand still? No explosion, no dimming, no sound, just silence. And within that silence lay a question that would shake our understanding of the cosmos. I-Atlas was first identified as an interstellar visitor, one of the rare few known to cross into our solar neighborhood. Its orbit was hyperbolic, unbound, slipping past the Sun's pull, destined to leave forever. As it journeyed inward, it behaved like a typical comet, shedding gas and dust, developing a coma, flaring with activity. Instruments tracked its emissions, mapped its trajectory, and measured its velocity. Everything about it, its speed, brightness, and spectrum, fit within the known framework. A normal comet, perhaps, but one carrying the fingerprints of another star system. Then came the anomaly. Multiple telescopes recorded it, ceasing to move relative to the background stars. Frame after frame, its predicted path dissolved. 3i Atlas had become a fixed point of light in a universe built on motion. It wasn't a fleeting glitch. The effect persisted long enough to erase any chance of coincidence. Astronomers double-checked their equipment, recalibrated sensors, compared timestamps across continents. Everything returned nominal. The object was, by every visible measure, motionless. Such a thing shouldn't be possible. In celestial mechanics, movement is law. An object falling toward the Sun must accelerate. One receding must slow. There is no middle ground. No pause button in space. And yet, for a time, it hovered. Scientists were left reeling. Was this a failure of perception? Or were they witnessing something beyond the natural order? Could an unseen force, a field unknown to physics, be at play? Was 3i Atlas simply a rock or something more? Early explanations leaned toward illusion. Perhaps the imaging data had been misaligned, or the comet's brightness had dimmed so much that only its core remained visible, giving the illusion of stillness. But cross-checks ruled that out. Observatories on separate continents confirmed the same pattern using different instruments and methods. Even after accounting for atmospheric distortion, camera drift, and exposure overlap, the object remained fixed. Others proposed non-gravitational forces, comet jets powerful enough to counter its own orbital momentum. Comets often behave unpredictably, venting gas from uneven surfaces that can nudge them off course. But the scale required here was implausible. To neutralize motion at tens of kilometers per second would demand an enormous and perfectly balanced thrust, something no known natural jet could sustain without producing visible signatures. Yet no such flare appeared. Theories grew stranger. Perhaps 3i Atlas was not a passive comet, but an object interacting with unknown fields, magnetic plasma, or even relativistic distortions in space-time itself. In physics circles, whispers began of exotic matter, dark field interactions, even alien propulsion systems. No one claimed certainty, but the data forced open the door of imagination. As days passed, observatories trained every sensor they had on the still point. Some radio systems detected faint Doppler shifts, suggesting microscopic motion, still within the margin of error. Others found nothing at all. The contradiction only deepened the mystery. Teams scrutinized timing logs, cross-satellite synchronization and signal calibrations. Could gravitational lensing or relativistic light bending be fooling the eye? If so, the illusion was a masterpiece of cosmic precision. Attention soon turned to the comet's makeup. Spectral readings revealed a coma rich in carbon dioxide, far denser than typical solar comets, with unusually low water content. The CO2 to H2O ratio was among the highest ever observed. This hinted at an origin in colder, more remote regions of its native system. Its volatile chemistry and uneven temperature gradients might have triggered exotic thermodynamic effects. Perhaps a pocket of trapped gas had exploded beneath the crust, producing a momentary reactive force that countered its motion, a perfect cancellation of vectors. Such a balance would last only briefly, but long enough to appear frozen in space. Still, none of these explanations softened the impact of what astronomers had seen. Everything in the heavens moves. Stars rotate, planets orbit, asteroids drift. To witness true stillness was to glimpse a violation of the cosmic order. The moment challenged assumptions about motion itself. Could some interstellar visitors contain mechanisms, natural or otherwise, that allowed them to suspend movement? Then, without fanfare, 3I Atlas moved again. Slowly, subtly, its drift resumed, aligning once more with predicted coordinates. Its velocity returned to normal under the sun's pull. The pause was over, but its echo remained. Scientists scoured archives for evidence of similar pauses in other interstellar objects, Oumuamua, Borisov, but none showed convincing signs. Perhaps 3I Atlas was unique, or perhaps our instruments had finally become sensitive enough to see what was always there. If an interstellar object could momentarily defy motion, our models were incomplete. The foundations of orbital mechanics would need revision. Non-gravitational dynamics, internal structure and exotic energy fields might all play larger roles than previously believed. Future mission planning could even adapt. If such pauses were predictable, they might offer windows for interception or study. For now, the event stood as a challenge to everything we thought we knew about motion through space. The pause also carried implications for planetary defense. If natural bodies can stall or redirect themselves, how would we track an object capable of evading conventional predictions? Though no evidence suggested artificial control, the mere possibility expanded the definition of hazardous. Space might contain travelers far more complex than frozen ice and rock. Theorists began constructing new models. Could internal heat gradients, volatile reactions, or fracturing release thrusts powerful enough to oppose momentum? Could interactions with the solar magnetic field cause a conductive object to lock briefly in place? Others pushed further, asking whether unknown cosmic fields might bind to certain materials, creating invisible anchors in the vacuum. And then came the most daring idea, that what we witnessed wasn't a physical pause at all, but an illusion crafted by light, motion, and gravity. If the object's velocity and the curvature of space-time aligned just so, the resulting relativistic optical effects could make it appear perfectly still for an observer on Earth. Rare beyond measure, but not impossible. Nature, it seemed, was willing to exploit even the narrowest of possibilities. When motion resumed, telescopes caught subtle shifts, brightness fluctuations, spectral lines changing hue, a gentle brightening of the coma. No explosion, no fragmentation, just a quiet return to movement, as though the universe had released its breath. In that recovery lay a lesson. The cosmos still holds surprises for those who look closely enough. Scientists realized they had witnessed more than a curiosity. In those hours of stillness, 3I Atlas had opened a window into the hidden mechanics of interstellar matter. It tested the limits of our models, stretched the boundaries of reason, and invited us to reconsider the fabric of space itself. Around the world, observatories replayed their data in disbelief. No instrument error could explain what had been recorded independently across continents. Amateur astronomers confirmed it from their own backyard telescopes. The same patch of sky, the same unmoving light. What began as skepticism became certainty. The stillness had been real. Attention shifted from denial to exploration. Simulations modeled internal cavities under pressure, layers of volatile ice venting through cracks. Some runs reproduced partial cancellations of motion, but none could explain the eerie symmetry of the pause. Then researchers noticed something else, subtle rhythmic pulses in the radio data. Not random noise, but oscillations repeating over fixed intervals. Could the comet be resonating with its environment, caught in a feedback loop between magnetic fields and plasma waves streaming from the Sun? The heliosphere is not uniform. It folds and ripples like a great magnetic curtain. If 3I Atlas contained metallic or ferromagnetic material, it might briefly couple with these fields, halting its apparent drift. The possibility electrified plasma physicists. They imagined the comet not as a passive wanderer, but as a conductor moving through a sea of invisible forces. Polarized light observations soon confirmed traces of magnetically active minerals, nickel, cobalt, and silicate dust, glinting in the coma. Perhaps, they reasoned, 3I Atlas had momentarily aligned with the Sun's vast magnetic topology, anchored not by gravity, but by magnetism. Infrared data added another twist. During the still phase, the comet's surface temperature oscillated rapidly, bursts of heat followed by sudden cooling. The pattern was cyclical, almost rhythmic, and bore no relation to its distance from the Sun. It was as if the object were absorbing and releasing energy deliberately, maintaining equilibrium. No natural process should produce such regularity. This behavior sparked a radical thought. Could matter itself, under certain conditions, self-stabilize? Not life, not consciousness, but a kind of structural intelligence. Perhaps the materials within 3I Atlas formed thermoelectric gradients, generating currents that balanced external forces, a natural feedback loop born of physics, not biology. If so, the comet represented a new class of object, a self-stabilizing relic from another system, a remnant of ancient worlds designed by time and chemistry to endure. It blurred the line between inert matter and active system, between object and mechanism. The universe, it seemed, might already contain entities that behave intelligently without being alive. The discovery united experts across disciplines. NASA convened a cross-field consortium of astrophysicists, material scientists, plasma theorists, and mathematicians. Their mission: to build a coherent model that could reproduce the impossible. They factored in radiation pressure, electromagnetic flux, relativistic distortions, even potential quantum effects at macroscopic scales. In nearly every simulation, the object kept moving. Only in rare cases, when magnetic and radiation pressures balanced perfectly, did the pause reappear. The odds were infinitesimal but not zero. The pause of 3I Atlas, then, may have been the universe performing a calculation, balancing forces so precisely that motion for an instant cancelled itself. It reminded us that impossibility in theory does not mean impossibility in nature. When astronomers confirmed the comet's movement had resumed, a quiet exhalation swept across control rooms. Relief, wonder, disbelief, all merged into a single humbling awe. For those who had witnessed it, the stillness of 3I Atlas would not fade. It was a moment when the laws of motion seemed to hesitate, when the cosmos whispered that even its most ancient rules are not beyond question. The object moved on, continuing its path back into interstellar space. But the memory of its pause, its haunting calm amid the dance of creation, remained. It was not an end but an invitation, a reminder that even in a universe of endless motion, there are moments when the stars